Hello everyone, welcome back to my YouTube channel. Myself Kushi.D from Sri Venkateswara College of Engineering. Today's topic is cryptography. So we will be looking to what is cryptography, substitution techniques, Caesar cipher, monoalphabetic cipher, Playfair cipher, and Hill cipher. So we will be now looking to what is cryptography. It is a technique of securing information and communications through use of codes so that only those persons for whom the information is intended can understand it and process it, thus preventing unauthorized access to information. The prefix crypt means hidden and the suffix graphy means writing. Features of cryptography are as follows: confidentiality, integrity, authentication. So here we have types of cryptography. So in general, there are three types of cryptography. They are symmetric key cryptography, hash functions, and asymmetric key cryptography. So what are the main applications of cryptography? So one is for we have computer passwords, digital currencies, secure web browsing, electronic signatures, authentication, cryptocurrencies, end-to-end encryption. So before moving on to the techniques, we need to know few terms. So the first one what we have is plain text. This is the original intelligible message or data that is fed into the algorithm as input. The second one we have here is encryption algorithm. The encryption algorithm performs various substitutions and transformations on the plain text. Secret key. The secret key is also input to the encryption algorithm. The key is a value independent of the plain text and the algorithm. The algorithm will produce a different output depending on the specific key being used at the time. The exact substitutions and the transformations performed by the algorithm depend on the key. Next we have is ciphertext. This is the scrambled message produced as output. It depends on the plain text and the secret key. For a given message, two different keys will produce two different ciphertext. The ciphertext is an apparently random stream of data and as it stands is unintelligible. Next we have is decryption algorithm. This is essentially the encryption algorithm run as reverse. It takes the ciphertext and the secret key and produces the original text. So next we have is substitution techniques. So in this we have the two basic building blocks of an encryption techniques are we have substitution and transposition. So a substitution technique is one in which the letters of plain text are replaced by the other letters or by numbers or by symbols. So if the plain text is viewed as a sequence of bits, then substitution involves replacing plain text bit patterns with ciphertext bit patterns. Now we will be looking into Caesar cipher. The Caesar cipher involves replacing each letter of the alphabet with the letter standing three places further down the alphabet. For example, now we have plain text as meet me after the toga party. Ciphertext would be ciphertext is nothing but we are generating it. So that would be PHHW PH DIWHU WKH WRJD SDUWB. So to generate this there is an algorithm. Note that the alphabet is wrapped around so that the letter following Z is A. We can define the transformation by listing all possibilities as follows. So we'll be having plain text as this and ciphertext as this. So assign a numerical equivalent to each letter. So from A to Z, we will be assigning a numerical value for each and every single alphabet. That is, for A, we will be starting from 0. So since there are total 26 alphabets, since we are starting from 0, from A to Z, we will be having 0 to 25. Like for A it is 0, for B it is 1, for C it is 2, D3, E4, F5, G6. So in similar way we will be having till Z25. Then the algorithm can be expressed as follows. For each plain text letter P, substitute the ciphertext letter C. C equal to E of 3 comma P equal to P plus 3 mod of 26. A shift may be of any amount so that the general Caesar algorithm is, so this is the algorithm which I was talking to you all previously. So it means C equal to E of k comma P equal to P plus k mod of 26, where k takes on a value in the range of 1 to 25. The decryption algorithm is simply, so if we want to decrypt it, we will be using this algorithm, that is nothing but P equal to D of k comma C equal to C minus k mod of 26. It is known that a given ciphertext is a Caesar cipher, then a brute force cryptanalysis is easily performed. Simply try all the 25 possible keys. Three important characteristics of this problem is cryptanalysis, that is, the encryption and decryption algorithms are known. So this is for the encryption and this is for the decryption. There are only 25 keys to try. The language of the plain text is known and easily recognizable. So here we have monoalphabetic ciphers. Instead of shifting alphabets by the fixed amount as in Caesar cipher, any random permutation is assigned to the alphabets. This type of encryption is called monoalphabetic substitution cipher. For example, A replaced by Q, B by D, C by T, etc. Then it will be comparatively stronger than Caesar. So next we will be moving on to what is Playfair cipher. So the Playfair cipher encryption algorithm, it consists of two steps. So in this algorithm there are mainly two steps. So the first one is generate the key square, that is 5 cross 5. The key square is a 5 cross 5 grid of alphabet that acts as the key for encryption the plain text. Each of the 25 alphabets must be unique and one letter of the alphabet, usually J, is omitted from the table, as the table can hold only 25 alphabets. If the plain text contains J, then it is replaced by I. So since in the English alphabets we have 26 totally, but 5 cross 5 will consist only 25. So one letter has to be omitted from 26. So J is generally omitted. So when we find the J alphabet, it is replaced with I. The initial alphabets in the key square are the unique alphabets of the key in the order in which they appear, followed by the remaining letters of the alphabets in order. So second step is algorithm to encrypt the plain text. The plain text is split into pair of two letters digraphs. If there is an odd number of letters, Z is added to the last letter. For example, in case if the plain text is instruments, so we will be splitting it into two, like IN as one, then ST, RU, ME, NT, SZ. Why SZ? Because since IN is split, then ST, RU, ME, and nt. So S has nothing. The second element of S is nothing. So we will be writing it as Z. So what are the rules that we are gonna follow here? So the first rule is pair cannot be made with same letter. Break the letter in single and add a bogus letter to the previous letter. Suppose the plain text is hello. So when we split it, we get HELL as one pair. So LL is same. So what we do is we will replace it by a bogus letter called X, and then the L would be shifted with O. So here X is a bogus letter as I told. So then we would get after splitting as HELXLO. If the letter is standing alone in the process of pairing, then add an extra bogus letter with the alone letter. So here we have HE as one pair, LLOE. So here this is one pair, this is one pair, this is one pair. Now E is left alone. So Z is a bogus letter which is added. It is a bogus letter which is added. So next we'll be moving for rules for encryption. If both the letters are in same column, take the letter below each one, going back to the top if at the bottom. If both the letters are in the same row, take the letter to the right of each one, going back to the leftmost if at the rightmost position. If neither of the above rules is true, form a rectangle with the two letters and take the letters on the horizontal opposite corner of the rectangle. So let us see one example. So now we have key as Manachi and plain text as instruments. So the plain text here what we have is instruments, and we have split it as, after splitting we get it as INSTRUMENTSZ. So Z here is a bogus letter as we saw in the previous slides. So now what after doing the procedure, the encrypted text what we are getting is this one. So how did we get it is shown in these steps. So for the first one IN, we will be following the algorithms. So then after doing all the procedure, we will be ending up with this as the encrypted text. So next, moving on to the Hill cipher. Another interesting multi-letter cipher is the Hill cipher, developed by the mathematician Lester Hill in 1929. So the encryption algorithm takes m successive plain text letters and substitutes for them m ciphertext letters. This substitution is determined by m linear equations in which each character is assigned a numerical value. A is equals to 0, B equal to 1. Similarly, for all the letters, then Z will be equal to 25. So the important factor here is for us to know these three steps. So that is nothing but C1 is ciphertext 1 equal to K11 P1 plus K12 into P2 plus K13 into P3, a whole into mod of 26. So what is generally done here is we are taking a 3 cross 3 matrix. So when we take 3 cross 3 matrix, we will be generating this. So what are the main steps to be followed in this? So step 1 what we are following here is obtain the key matrix K. You need to know the 3 cross 3 matrix K that was used for encryption. This matrix is essential for decrypting the message. Step 2. Calculate the inverse of the key matrix, that is K to the power minus 1. That is nothing but inverse of the key matrix. To decrypt the message, You must calculate the inverse of the key matrix, that is nothing but k to the power minus 1. The key matrix must be invertible for the Hill cipher to work. Step 3. Convert the ciphertext to numerical values. Take the ciphertext you want to decrypt and convert it to numerical values using the same mapping you used during encryption. For example, A equal to 0, B equal to 1, C equal to 2, Z equal to 25. So in between, all other alphabets also will be mapped to the numerical values correspondingly. So next we have a step 4. Group the numerical values into blocks of 3. Since you have a 3 cross 3 matrix, group the numerical values into blocks of 3. If you have any leftover values, you may need it to pad them. Step 5. Perform matrix multiplication. Multiply each block of numerical value by the inverse of the key matrix. To do this, calculate the dot product of each row of k to the power minus 1 with each column of numerical value block. Step 6. Take the modulo 26 of the results. After matrix multiplication, take the modulo 26 of each result. This ensures that the values remain within the range of alphabets 0 to 25. Step 7. Convert the numerical results to letters. Convert the numerical results back into letters using the same mapping as in step 3, that is A equal to 0, B equal to 1. Similarly for others till Z equal to 25. Step 8. Combine the letters. Combine all the letters obtained from step 7 to form decrypted plain text. So these are the steps to be followed. So that's all for today. Thank you for watching my video. Please do like and share.